Alright guys, here's your podcast for section 9, write polynomial models. There's only like 4 examples here, so here we go. Example type number 1, write a cubic function. What you need to pay attention to, whether I give you a graph or not, pay attention to the coordinates. Here's a 0, here's a 0, here's a 0. When you have zeros, you also have factors. So if negative 4 is a 0, then x minus negative 4 is a factor. If 1 is a 0, then x minus 1 is a factor. If 3 is a 0, x minus 3 is a factor. So your setup should be this: y equals all your factors times it by a, because really there could be lots of equations or lots of functions out here that could represent these 3 coordinates. Okay, so that's why they give you a whole nother point to work with. So whenever you get something like this, you plug in all of the factors, all of the zeros into the factors, and then you use the other point, the 4th point, and plug it in for x, all the x's, and the y, right? So 0 is x, and negative 6 is your y value. So just plug them in. So y is equal to negative 6 equals a, we don't know. X is, I plug it in for now, 0 plus 4. X is 0 again, minus 1. And x is 0 again, minus 3. Everybody see what I did? I just plugged in x for 0 for x and negative 6 for y. Look what's left over. A is left over. Negative 6 equals 4 times negative 1 times negative 3 gives me positive 12. A. So divide by 12. A equals negative 1/2. We found A. That's all we need for our final. Just put it back in here and you're done. So y equals A is negative 1/2. X plus 4. I don't have enough room. X minus 1 times x minus 3. Sorry for the sloppiness here. But here is your function. So the only thing to do for an example like this is plug in your zeros, which make factors, and then plug in your x and y value that help you find your a value. That's the goal. Get your a. Here it is. Plug it in with your factors and you're done. A lot of people will multiply these. Please don't. Just leave it the way it is. It's fine. So that's example number 1. Okay, the next example I want to show you guys is a concept called finite differences. What we're going to do is we're going to find the differences of the y value. So you can take any table, any function, and do this to the function. Watch. I'm going to just take these two. I'm going to subtract negative 7 minus 0, which is negative 7. Then take these two. Negative 4 minus negative 7, which is positive 3. And take these two, subtract 21 minus negative 4, which is 21 plus 4, 25. Take this one minus this one, which is 59. Take this one minus this one. Notice what I'm doing. I'm always taking the right one minus the left one. Right one minus the left one, so on and so on. That's important to know. Okay? Never just kind of mix them up and say, okay, this minus this. Always the right minus the left. So this one is 105. What we found is we found the differences. We did it one time, so that's why this is called the first order differences. Okay, we're going to do it again. Do these ones, these two. So 3 minus negative 7, 3 plus 7, 10. 25 minus 3, 22. 59 minus 25 gives us 34. And 105 minus 59 gives us what? 46. Alright, so this is the second time we subtracted. We have found the difference. So this is called our second order differences. Okay, so you're saying why? What's going on here? Well, check out the third time we do it. Here, 22 minus 10, 12. 34 minus 22, 12. 46 minus 34, that's also 12. We found the third order differences to be what we say is constant. It's constantly 12, right? So we say the third order differences are constant. So that means something, okay? Since it's the third order, what this finite differences actually means, what it actually tells you is what degree your polynomial is. Like this thing right here is a table, right? Every table just about can be represented by a function. You know, y equals 5x squared, so on and so on. So what this tells you is, since not the first, not the second, but the third is all the same, that means it is a third degree function. That's what this means. Because it was the third order differences that were constant, that were the same. Now if all these were the same, the second order, this thing would be a second degree, which means it's a quadratic. Okay? Get the idea. Alright, so what you need to know is finite differences tells you the degree of any table, any polynomial. Okay? Just subtract the y values. That's all you subtract. There's a couple things to keep in mind though. One, the x values have to be equally spaced, meaning this 1, 2, 3, 4, 5, 6. They're all spaced by 1. It couldn't be like 1, 2, 5, 9, 12. You wouldn't be able to do finite differences on that. They ought to be spaced the same. So it could be 0, 5, 10, 15, 20, so on and so on. Keep that in mind. And then it's always the right one minus the left one. The right one minus the left one. That's how you get your differences. So this is what we call finite differences. So in the book here, it shows you about finite differences. So I just kind of took a picture of it. Like I said, when the x values in a data set are equally spaced, the differences of the consecutive y values. So we're taking the differences of the y values and we're calling them finite differences. Okay, so they show you an example here. It could be looking a little bit different than what I showed. I showed you a table. This is basically a table. F of 1 means when x is 1, the y value is 1. So this is like telling your x and your y. When x is 2, the y value is 4. So when x is 2, y is 4. So this is basically a table. Okay. So what they did was take the difference of this one and this one. Difference of those 3. Difference of this one and this one. There's 5. Difference of this one and this one. 16 minus 9, 7. Now they got the first order differences, but they're not the same. If you took these differences, 5 minus 3, that's 2. 7 minus 5, there's 2 again. We got the second order differences to be the same, which means this is going to be a quadratic. So, just so you know, the finite differences. Example 2. So here's what we have, real quick. They give you a function, okay, and they tell you basically the table of the function, which is nice. So you don't have to really do much, except pay attention to the wording. It says show that this function has constant second order differences. Okay, all you got to do is show me that the second order is constant. So watch. These are the y values, right? Here's x, here's y. So x, y, here's x, here's y, here's x, y, so on and so on. All we got to do is take differences of y values. 1 and 3, 2. 3 and 6, 3. 10 minus 6, 4. 15 minus 10, 5. There we go. There's our first order differences. And you could probably see if we take the second right here, there's 1, 1, 1. The second order differences are constant. This problem is just showing me the work, okay? Which is hard for people to see sometimes. They think they have to do something else. It's just showing. See? See that question? Show. So that's all. This is what you would have on your paper on the test right here. Show me it has second order differences. Okay? That's example 2. And here's a little note about finite differences, some properties. Okay? If a polynomial has degree n, whatever number you want to stick in here, then the nth order differences of the functions, the equally spaced x, are constant. The differences are constant, and they're non-zero. Like when you do the differences, you won't end up to be 0 as a difference. Okay, any number. Okay, the converse of this is true. Here's what this means. Give an example. If a polynomial has degree 3, okay, let me give you a polynomial. Y equals x cubed, okay? then the nth order, so then the third order differences in this case of the function are constant. So if you made a table out of this, you would see that, okay, first order differences not the same, second order differences not the same, third order differences are constant. That's what you would see. Then second property, the converse is also true, meaning this: if you see first order differences, okay, second order differences, third order differences, if you see, oh, I got all 2's for third order differences, oh, that means that it has degree n, or degree 3. That's what I was showing you before. Finite differences basically tells you the degree of the polynomial. Okay, you can practice some of those on your own. So example 3, we're going to find the polynomial function. Find the function that gives this pyramidal number. So the first 7 triangular pyramidal numbers are shown below. So when x is 1, the output is 1. The second number gives you an output of 4. There's 4 here. The third one gives you an output of 10, so on and so on. Basically, all this is this. They're giving you a table right here, okay? So here's your table, which doesn't look like a table. All you have to do first is, it wants a function, right? Like it wants y equals ax to some power, ax to the n, blah, 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 blah. What do you have to figure out? You have to figure out what degree it is, okay? How do you figure out what degree something is? You find the finite differences. Okay? First thing you have to do, step 1, you can write it down. Find the degree of this table. Okay? Here we go. All we have to do is finite differences. Watch. Subtract all the y values. So 4 minus 1, 3. 10 minus 4, 6. 10, 35 minus 20, 15. 56 minus 35, 21. And 84 minus 56, that's what, 8, 28. Okay? So, next. The first order differences are not the same, so do it again. 6 and 3, there's 3. 6 and 10, 10 minus 6, 4. There's 5. You can see a pattern. 21 minus 15, there's 6. 28, there's 7. The second order differences are here. Still not the same. Here's 4 minus 3 is 1. 1, 1, 1. The third order differences are constant, which means it is the third degree, okay? So that means it would be y equals ax to the third something, something, something. Alright? Now, what do you do now with that? All you have to do is type in your table into your calculator. So basically this is a calculator problem besides showing me that, oh, you know it's a third order, which means it's a third degree. If it's a third degree, it's called you should know, a cubic function, right? We know based on this table that this is a cubic function because of finite differences. Okay, now how do you get the function based on the table? You've done this before. You're going to type in your table into the stat key. Remember that? Remember doing that? Table into the stat key. So the process is, everybody hit your stat button on your calculator. So stat. Okay, you're going to go to edit like you've done before. You're going to edit your lists. Right? So list 1 is always your x values. So all your x values, it started with x was 1 and 2 and 3. So put all those in up to 7. Right? You scroll over, and your L2 is your y value. So you just have to look at this thing right here, all your y values in here. So type in, let's see, 1, 4, 10, 20. 1, 4, 10, 20, and 35, 56, 84. 35, 56, 84. Okay, there you go. You got your list. All you have to do is hit stat, scroll over to calc. So scroll over and look down here. Now here's the deal. I don't have to give you a cubic What if you got second order differences were the same? That means it would be a quadratic, right? So you have to choose whatever it is based off of finite differences, okay? So since finite differences told us it was a cubic or third degree, that's what we hit, cubic reg. Hit that. There we go. Most of you can hit enter right now and it'll give you the answer. Some people, if you use different lists than list 1 and list 2, you have to type those in. So if you hit, if you put X's in list 2, comma, second list 3, then you can hit enter after that. So, but I did not, so I will delete those. Okay, so cubic reg, enter, and this is what you get. Now, you guys know I like exact answers, so what you will need to do is put this in the calculator. 0.166 the whole way across the board, hit math frac. Okay, so we'll do that right now. So 166.5 and 3. So you know B is 1/2. You know C 0.3, that's 1/3. Most people maybe not know 0.16, so we'll do that. So 0.1 and 66 the whole way across. Now I know it shows 7 up there, but that's what the calculator did. The calculator rounded, so 1/6. Excuse me. Hit math, frac, enter. There you go. That's 1/6. So it was 1/6, 0.5, so 1/2, and 0.333, so which is 1/3. So final answer. If you change everything, notice the book does something different. So the book uses matrices. You could use the book, that's fine. We've done that before, but I think it's a little bit more work, right? So notice I got the same answers as this right here, and which turns out to be this. So 0.166, that's 1/6. 0.5 is 1/2. 1/3 is 0.333. You need to have this answer right here. Okay? So change all those to fraction. That's example type number 3. So you want to find a model, meaning you want to find an equation, okay, for any table that I give you. So if I gave you this table, go ahead and try that. Find the function. Notice it doesn't say what are the finite differences. It says what is the function that represents this table. So step number 1, you need to use finite differences to tell me what degree it is. Step number 2, plug it all in the calculator and hit whatever it is. If it's a quadratic, hit quad reg. If it's linear, hit lin reg. If it's cubic, hit cubic reg. If it's a quartic, same thing. Okay? So try that, pause that, try it. Here's your answer. There you go. So example 3 is done. Alright, the last problem here, example 4. Basically, all you have to do, they're giving you a table again. This always comes back to this. They're asking you to find the polynomial model or the polynomial function for this data. So one, you have a table, so you don't know if this is linear or quadratic or whatever it is. And that's why we normally use finite differences, right? If we find the differences of these and see what degree it is. But in this case, because it's a real life problem, I don't think if you find the finite differences, it's going to be all the same. They're not going to be constant at some point. So what we have to do is rely on some other skills that we have. So what we're going to do is use the calculator. Okay. In this calculator, what we're going to do is we're going to plug all these points in our list and then look at the graph. Okay. So if we look at the graph is going to show us something if we plot these points. So we plotted points on a graph before in our calculator, so let me give you a refresher how to do that again. So if we already did this, typed it in, first thing you want to do is hit stat, hit edit. In your list 1, you want to type in all these numbers from the table that they gave you. List 2, all the y values from the table that they gave you. Okay, so go ahead and take a minute to do that. You can pause it, type them in. Alright, now once you get all these in your list, you don't want to hit stat calc yet because you don't know what degree it is. You don't know if it's linear, quadratic, cubic, quartic, and so on. So what you want to do is you actually want to plot those points. Alright, These are all coordinates. So let's plot these coordinates on a graph. So if you hit the graph button, you're not going to see it. So what you need to do is remember turning your stat plot on. Remember stat plot? You're plotting points. Turn that on. So go in there, turn it on. The type, that's your type that you want. X list, L1, Y list, L2. Unless you changed yours, you should change these too. Whatever list you use. List 3, list 4, you change them. Mark whatever mark you want. Now, even if you hit graph, you're still not going to see it. You're just going to, I'll even do it for zoom 6. Here's what you're probably going to see. That's all you're going to see, even though your stat plot is on. So, why? Because look at look at these numbers. X starts with 10. You think about your window right now. Your window goes from -10 to +10. This starts at 10. It keeps on going to 80. Look at your Y value. Start at 200 and go to 2,000 some. So what you need to do is get good at changing your window. So change your window. So go over here. X started with 10, so I'm going to just start at 0. X max, if you looked at your table, it was 80, so I'll go 90, just a little above. X scale, it doesn't matter. Y min, we started our Y values at like 200, so I'll just say 190, a little bit before. And Y max, it was like 2002 something, so I'll say 2400. Hit the graph now. Now look at what you have. Now this is how we're going to find out what degree it is, just by looking at this graph right here. Now what does that look like? Does that look linear, quadratic, cubic, quartic? And if you look very close, which it's kind of hard to see, but you see it going up and then a little dip and then it goes up. So it's kind of doing this right here. Okay, maybe you'll see it in here better. Here's what it looks like here. It goes up and a little dip. There it is. So kind of looks linear, right? But if we look real close, it's actually a cubic. You know, cubic. You think of a cubic maybe more like this, right? But it could be ever so slight, right? So since it's a cubic, since we know it's this, degree is 3, just based off of looking at this picture, you want to go back to your calculator and say, okay, well, stat, you already have it in your list. Go to calc, and since you know it's a cubic based on the picture, you go on a cubic regression. Hit enter, enter again, and this is what you find. Now the only thing you have to do here is you have to round, okay? 0.007 B, you know, just round to a couple decimal places, or the first one has to be like 3 or 4 decimal places. So just be able to round correctly, okay? This is not going to be turned back into fractions. Weird numbers here. Okay, so you write that on paper and you're done. Just plug in A, B, C, D into the formula up above that you see, and you're done. So let's see what they do. They might do a little bit different. No, they do cubic reg. They got the same thing I did. Notice how they put just a bunch of decimal places here. They rounded here. So that's it. All you guys have to do for example number 4 is you have to look at this to find out what degree it is, like degree of 3, and then type in cubic regression in your calculator, and then it'll spit out this right here. Then you write this answer down, and this is the model that models that table that you saw. So this is it for section 9, finite differences, and you will see some of these questions on the test next class. So good luck, study hard.